All right, so I in that first video I sent you, I did give you the answer, the breakdown of number 10, which I think was your in your original question. 19 and 21 are not as easy, I guess, or you're gonna have to definitely factor and foil both of these. So let's take a look, dive right in here at number 19. Let's go ahead and get our setup here. I like to work in this case. I'll work from top to bottom again. Like I said before, there's 3 or 4 different ways to set this up. But if I just work from top to bottom, I'm going to compare x minus 5 is to x minus 1. Then as x minus 2 is to 2x plus 1. So obviously in this case, when we cross multiply, we're going to need to foil or use the box method, whichever one you choose to use. So if we do this, we cross multiply, we get x minus 5 times 2x plus 1 is equal to x minus 1 times x minus 2. Okay, so what I'm actually going to do, well, we're limited on space here, so I'm going to need to go ahead and copy this down into a blank piece of paper here. Let me write down this so I can copy this over. Okay, so I'm going to go to a blank document here. This way I can do the work here and have plenty of room. So I'm going to copy down what I had. We've got x minus 5 times 2x plus 1 is equal to x minus 1 times x minus 2. So we did the cross multiplication. Now, like I said before, I'll foil one of these and I'll box the other. So I'll foil this one first. So first, 2x times x is 2x squared. O is outer. So I get a plus 1x. I is inner. I get negative 10x. And then last is negative 5. Combine my like terms, I get 2x squared. These are my like terms. That gives me negative 9x minus 5. Okay, so that was FOIL. And again, it doesn't matter how you do it. If I were to box this next two binomials, I get x minus 1, x minus 2. Again, to get the value inside the box, I got to multiply the two things outside. So this times this is x squared. It goes in this box. Okay, negative 2 times x is negative 2x. To work in the top right box, x times negative 1 is negative 1x. And to get the bottom right box, it is negative 2 times negative 1 is a positive 2. Now, these will be your standalone, no common terms to combine. And then if you set it up the same way I do, you will always end up having these being your like terms. You get negative 3x. And then, of course, you still have your plus now, 2. So, your new equation reads 2x squared minus 9x minus 5 is equal to x squared minus 3x plus 2. Okay? So you have to get one of the sides of the equation to be 0 because there's no way to solve directly for x. You have x squareds on both sides. So let's go ahead and move all of our terms on the right-hand side, and let's move them over here. And I'm choosing to do that because I don't want my a term, my x squared term to be negative. So I'm going to do whatever I can to avoid that. It just makes the factoring easier if I don't have to do that. So minus x squared. This will cancel. We'll add 3x. Make sure you're adding to your like terms. Those will cancel. Minus 2. Minus 2. So the right-hand side now becomes 0. 1 subtracted from 2 is 1x squared. Negative 9 plus 3 is a negative 6x. a negative 5 minus 2 is a minus 7. So there is our new equation. Now we've now we've FOILed them. Now we need to factor out our polynomial to get our two answers. So in this case, I need to do 1 times 7, which gives me 7. And I'm going to list all the factors of 7. So the only two numbers I multiply to give you 7 are 1 and 7. So what I have to do now is I'm going to rewrite this term, but I'm not going to call it negative 6x anymore. I'm going to replace it with these two terms. Now, in order for 1 and 7 to combine to give me a negative 6, the 1 has to be a positive and the 7 has to be negative, because if I were to combine or add those up, that would give me the negative 7 the negative 6 that I need. So I'm going to rewrite this middle term by breaking it up to negative 7x and a positive 1x. And then nothing else in the polynomial changes at the moment. Okay? So the practice of this was called AC grouping. Well, I multiplied the A and the C term, so I took care of the AC part of the name. The second part is called for grouping. So I'm going to put the first two terms in parentheses and the last two terms in parentheses. Now I'm going to check for the greatest common factor here. The only greatest common factor in that first set of parentheses is an x. When I factor out an x, I get x minus 7. Now, here, there's really nothing to factor out. The only thing that you can take out is a positive 1. That doesn't change anything in the binomial, but it does allow me to at least take out a 1 because I have to take something out. At this point, you need to check. Does this and this match? If it does, it's perfect. That means you're on the right track. If it does not match, you made a mistake. What's left over after we factor out this x minus 7 is x plus 1. Now, again, there's that property that says if we have two things that are multiplying to give you the product of 0, one, if not both, are equal to 0. Well, that means either x minus 7 is equal to 0 or x plus 1 is equal to 0. Solve each one for x. X comes out to be 7 in this case. Solve this one for x. You get x equals negative 1. Now, the answer key says the answer is only 7. Why? Well, because if x is negative 1, that tells me that a length is negative, which is not possible. So this must be your only answer there for number 19. Okay, a negative value cannot represent a length. Now, your second question, I believe, was number 21. So let's go back to 21 here. And let's take a look at it. So, again, it depends on how you set. Well, it doesn't depend on how you set it. Just know you can set it up. If you set it up differently than I do, that's fine. I'm going to, again, go top to bottom. So I will say 3x plus 1 is to 4x plus 4 as 2x plus 2 is 18. Now, the nice thing is, I look at this, I only have to do the factoring or the foiling one time here, but it is still going to require, I think, factoring. So let's put everything in parentheses, and I'm probably going to have to do what I did before. I'm going to have to copy it over to a second page here so I have enough room to do the work. But if I cross multiply, and I'll write this in blue, that will give me 18 times 3x plus 1 is equal to, and this is where you're going to have to do a FOIL or box, 4x plus 4 times 2x plus 2. Okay, so again, I'm going to copy this down and over to a blank page on here so that I can do the work. Let's see if I still have my blank page here. Okay, so we'll work on this next page. Alright, so we had, and the cross multiplication I assume is good, that's the geometry part of it really. This is now the algebra fun part. Okay, so this should be easy. Alright, if we go ahead and double check when we distribute here through, we get 54x plus 18 is equal to. Now, again, I'm going to box this. I think it's more student friendly. If you want a foil and you want to see this done using foil, just let me know. I'd be happy to do that for you. So copy down our value. So again, to get inside the box, you need to multiply the terms that are outside of it. So 2x times 4x gives you 8x squared. 2 times 4 gives you 8x. Now to work in the top right, 2x times 4 is 8x, and to get the bottom right, 2 times 4 is 8. Crazy 8s here. So when I go to combine my like terms, again, they will be, if you set it up the same way I do, the values in the bottom left and top right. And if we want to write this out, we get 8x squared plus 16x plus 8. So that is the second half of my equation here. 8x squared plus 16x plus 8. Okay. So let's go ahead and bring this down. So I have a little bit of room here to work. Actually, no, we'll just erase this. Okay, so again, you have an x squared, so you're going to have to factor, and again, I would advise that you keep your x squared term positive, so we're going to minus the 54x from both sides. When I do that, and I minus my 18 from both sides, I have 0 is equal to 8x squared. Minus 38x minus 10. Okay, so looking at this, this is, again, something you mastered in Algebra 1, or should have. So the one thing I need to look for, and a red flag for this, is the fact that these numbers are all fairly large, okay? And I need to ask myself, what's the greatest common factor between 8, 38, and 10? And that value is 2. So I'm going to simply divide every single one of these coefficients by 2. Now, this 2 that we factored out, we're just going to kind of ignore it and kind of, I hate to say pretend like it doesn't exist, but that's kind of what we're going to do. So we need to do, again, AC grouping. Now, we are only dealing with the stuff now inside these parentheses. So my A term is now 4, my C term is now 5. The product of those two numbers is 20. So I'm going to list all the factors of 20. So 1, 20. 2, 10. 3 is not a factor of 20, but 4 and 5 are. Now, I know I'm done listing all the factors because the next number I'd pick after 4 is 5, but 5 already shows up on my list. So there's no need to keep going. I've listed all the factors. Now, I need the pair of factors that will combine to give me a negative 19, and that is 1 and 20. The 20 has to be negative. The 1 has to be positive. So again, we're going to pretend like this 2 doesn't really exist. I'm going to rewrite this part of the polynomial, but I'm going to break it up into a negative 20x and a positive 1x. Everything else will be written the exact same way. So 0 equals, we have 4x squared minus 20x plus 1x minus 5. That's the AC part of it. Now we need to group them. So if I put these in parentheses. Now this is a little bit more challenging only because of the fact that the GCF is going to be a little bit bigger here. Greatest common factor in this set of parentheses is both a 4, because 4 is a factor of 4, but it's also a factor of 20. And every term has an x. The lowest exponent between the x's is x to the first. So I divide every single one of these terms by a 4x. 4 divided by 4 is a 1. X squared divided by x is x. Negative 20 divided by 4 is a minus 5. The x's cancel. Okay, so that is probably the second hardest part of this, is that GCF part right there. Okay, now over here, Looking for the greatest common factor. Again, there really isn't one. It's just simply a positive 1. So if I factor out a positive 1, then, nothing really changed. I just took the positive 1 technically out. Okay, but 1 divided by 1 is 1. Negative 5 divided by 1 is negative 5. Nothing's different. But the important thing is these two terms are exactly the same, which is what I need. Okay, so when I go to do this, I have x minus 5. I factor that out, leaving me with 4x plus 1. Technically, that 2 that we originally factored out is still there, but it doesn't really do anything for us because there's nothing really to worry about. But the rule does say three of these terms multiply together to give me 0, which tells me that we have to see what they all solve for in case of 0. Okay? 4x plus 1. So, clearly not applicable. We can't solve a 2 never equals 0, so that's not even a solution to the set. Add 5 to both sides here, we get x equals 5. And this one is a 2-stepper. Minus 1 from both sides, we get 4x equals negative 1. Divide both sides by 4. X is equal to a negative 1/4. Now, I know in the last problem I said the x can't be negative. However, if we go back to the problem, the answer choice was a negative 1/4. Okay, so if you see on the answer, I think we're all in cahoots as to why 5 is the answer. But negative 1/4, you're like, well, wait a minute. The other one was negative. You said it couldn't be allowed. Well, correct. But in the other one, let's go back to the other one here, number 19. The second answer, I think, was a negative 1. If I recall correctly, if that's the case, and I put negative 1 in for x, that tells you this length is a negative 2, which is what really is not possible. Same thing here. If I put a negative 1 in here for x, that gives me a negative 6. That's not possible. If I go back to here, and I put negative 1/4 in, well, let's put it into this expression right here. Okay, this gives me negative 1/4 times 4 is a negative 1, plus 4. That tells me this length is 3. That's acceptable. Okay, so x can be negative if it still yields you a positive or a true length for or value of a length. Okay, same thing here. This would give me negative 3/4. But if I add 1 to that, that number becomes greater. It's 1/4. Okay, so you have a positive answer for all of these. Even if you put a negative 1/4, that's why they're both acceptable for an answer. Okay, as always, if you have any more questions, shoot me an email, and I'll be happy to get back to you.